Okay, welcome back. We are going to do two lessons. They're very short. One's 2 pages, the other's 3 pages, on the second part of function notation, and then also looking at problem solving of functions. Okay, so 471. So the first thing we're going to look at, graphing a function. Okay, so just a reminder that the x is the input and makes up the domain, and then f of x, okay, that's our y, or our output, and it makes up the range. Okay, so in previous lessons we would look at this type of an equation, okay, and now we've been doing the oopsies we've been doing the function notation like this. So f of x is equal to 3x plus 1. So we can write it in either one of the function notation or xy notation. Okay, so reminders. We've said this a bunch of times, so you should definitely have this ingrained in your brain here. So the inputs are your horizontal axis, which is your domain, and then and independent. So those are all the things that are synonymous. And then your dependent variable are your outputs on your vertical axis and are your range. Okay? So, use a graphing calculator to sketch the graph of the function. Okay, so I'm going to show on the Inspire. I don't have one of the other ones. So, the other ones you would do the y equals, and then you would put this in. Okay, I'm going to clear this. Delete all. Yep, sure do. Double tap. 3x plus 1. There's my line. Okay, so the graph that they give you there, okay, you just need to add on the, that it crosses that point right there. So you want to know any of the points. So if you go into the 0, okay, we can find out, whoa, the 0 is happening at negative 0.333. Okay, so that's 1/3, negative 1/3. Okay. So negative 0.33, we'll just say repeating. And then the x-intercept, or sorry, the y-intercept is happening at 1. Okay, and so you could do that to oh my gosh. Sorry, this is the 1, 2, 3, 4. This is the 5th lesson that I've done after class, after doing a bunch of lessons. So I'm going to try to be as coherent as possible, but you might have to be patient with me. So anyway, you can do this one of 2 ways. You can recognize that that's the constant, okay? Or remember, you could go into your tables, menu, table, split screen, and the y-axis is when x is equal to 0. So there's my 1. Okay? So either way, that's all we would have to do for this question. Okay. For question 2, in each case, express the relation given in function notation as an equation in 2 variables. All this is saying in 2 variables. Now I'm going to write this as y. Okay? Same thing here. And I could have picked something other than y. Okay? I'm going to pick y here too, because why not? Okay? Now this is going backwards. Express the relation y is equal to 11x minus 15 in function notation. Okay, well you just pick an, it could be f of x, g of x, h of x, as long as it's of x. Okay, because that x right there. Okay? And then same thing here. If y is equal to f of x, has this equation, express the equation in function notation. Okay, we're just substituting in that f of x. Okay? Alright. So then, there's one class example for us to do. So, the graph of a function f is shown. So, complete this. So, if I'm substituting in all of these x's, I'm just reading it off the graph. So, remember, this is x. So, when x is equal to 5, what's the overall function? Okay, well, let's see. When x is equal to 5, there's my overall function at negative 2. Okay, same thing when x is negative 2. right there. Okay, well, in order to meet the line, I have to go up for that one. Oopsies. Okay, so then that one's going to be equal to 3, and then I'll give you a second to do f of 4. Okay, so over to 4 would be there, which is -1. Okay, so then writing the ordered pairs associated with these, well, remember, x always goes first, so you would just do 5, -2, -2, 3, 4, and -1. Okay? Alright, so now state the values of x. So this is the opposite. Here we were given x and we were asked the y. Now we're given the y and we're asked given the y and asked the x. So if y is equal to -1, okay, well I go down to -1, and there's nothing this way, it's this way right here. So -1 is at 4. Okay, for y is equal to 3, okay, so I go 1, 2, 3. Okay, so you'll notice there's actually two answers here, which is fine. Okay, so there's going to be, it's plus and minus. Oopsies, x is equal to plus and minus 2. And then when y is equal to 4, okay, same thing, right there, at plus and minus 1. Okay. Okay, so use the notation in A, so that's this one here, to make a statement about points A and B. Okay, well there's point A, there's point B. So it's saying we want f of something is equal to something else. Okay, well f of A, or sorry, point A is at -5 is our x. Okay, and our y is 1. Okay, so I'll let you do B. Okay, so hopefully you counted over to 5, so that's 6, and then down to -3. Okay, part E, write the x and y intercepts of the graph using function notation. Okay, x-intercept is when y is equal to 0. Y-intercept is when x is equal to 0. It's always the opposite. Okay? So when y is equal to 0, okay, that's going to be f of something is equal to 0, whereas my y-intercept when x is equal to 0, that's going to be f of 0 is equal to something. Okay? So for the first one, for my y-intercept, okay, well that's going to be this right here. Okay, that's going to be happening at, or sorry, I just said this one. Okay, so my x-intercept here is when, oh my gosh, okay, I'm okay. My y-intercept is when x is equal to 0, which happens at 5. My x-intercept is when y is equal to 0, okay, and my y is equal to 0 at 3 and -6. So this one actually has two x-intercepts, which is fine. Okay? So then complete the following statements for domain and range. So the domain of f is such that x is such that, so then in between these two numbers, so we always go our lower and our highest, so we got -6, and our biggest number here is 7. Okay, and then my range, okay, is going to go from, what is that, 1, 2, 3, 4, -4, up to 5. There we go. Okay. So overall, just being able to relate back and forth between x's and y's. We're still looking at our domain and range. We're still using x and y intercepts, etc. Okay. So you will get time to work on this, but we are going to go on to lesson 10, which is just this page. Okay. And it's on Page 477. Okay. So this is all about problem solving. So we're not really learning anything new here, we're just applying what we've been talking about. So in lessons 2 and 3, we solved problems about relations defined by an equation. In this lesson, we're going to solve problems where function notation is used to define the relation. Okay? So in lesson 3, there was a question, an assignment question. It was talking about candles, and it had a formula that they melt. Candles melted according to the formula H is equal to negative 2T plus 12, where H is the height of the candle and T is the time. So the relationship is described by an equation. And then the relation is a function because, and this is our definition, for each input there's only one output. Okay? So then the function notation can be used. Yeah, that's the same. In this example, the notation H of 4 is a simplified way of representing the height of the candle after 4 hours. Okay, because T is equal to 4, I substitute that in. Okay. So, a candle manufacturer found that their long-last candles melted according to this formula, where H is the height and T is hours, height in centimeters. So use a graphing calculator to sketch the graph of the function and show it on the grid. So now remember, instead of T's, we're putting in X's, because our calculator is programmed to only have X's and Y's. Okay, so I'm going to clear this. Then I'm going to put in negative 2x plus 12. There we go. Okay, and this makes sense that it's going down because the height of the candle is going down as it burns. Okay, so I'm just going to move this around so that I can graph it. And oh, this is like awkward. Okay, well, this is getting old, so I'm going to just draw it. Doop. Okay. So that's the graph. I'm going to want to find out those 2 points right there, okay? Which I can do algebraically or I could do graphically. So for this point right here, I want to know what the height is, okay, when T is equal to 0, okay? So once again, I could do that one of 2 ways. I could recognize that it's just going to be 12 because that's the constant, or I could go and I could look in my tables, my table of values, so I'll show you that, maybe. There we go. Table, split screen, and then I go up. When x is equal to 0, okay, that's my 12. I can also look at my table for when y is equal to 0, so sometimes it's perfect on there. Yep, it is. So when y is equal to 0, it is 6. And by it, I mean x. Okay? So determine the value of h of 5. Okay, well, h of 5 is when x is equal to 5. So since I've got my table out here, I see it's going to be equal to 2. Okay? Sometimes it doesn't work out that nicely because of just whole numbers, etc. But I know it's going to be equal to 2. Okay? But I'm also going to show my work so that I can get that algebraic practice. This is supposed to be 5, sorry. h of 5. Then negative 2 times 5 plus 12. Okay, negative 2 times 5 is 10. Negative 10 to be exact. Negative 10 plus 12 is equal to 2. Okay? So then what does that mean in the context of our problem? Okay, well that means that the height of the candle after 5 hours is 2 centimeters. So the height of candle after 2 hours, after 5 hours, is 2 centimeters. Okay. So then, basically we're going to do the same thing for D. We're going to evaluate the 3 and explain their significance. So the significance of this is the starting height, because that's at time 0. That's at time 6. How high is it? That's at time 8. And those times being all in hours. So we're still using our formula of h of t is equal to negative 2t plus 12. I'll just write it down there so we can see it still. And then we're substituting it in. So h of 0 is going to be equal to negative 2 times 0 plus 12. Okay, well that's just going to be 12. So at time 0 hours, the height is 12 centimeters. So that's going to be the max height, right? Because we can't go into negative time. So then 6, okay, so negative 2, 6 plus 12, okay. Negative 2 times 6 is 12. And because that negative sign, we've got 0, okay. So this means that after 6 hours, the candle has burnt down. Okay. And then of 8, so I just substituted in. Negative 2 times 8 is negative 16. Okay, so now this has no meaning because you can't have a candle with negative height, right? So no meaning because of the context of this question. Maybe, like, you know, if it was something else, it might have context, but for this one, it doesn't. Okay. How long will it take for the candle to burn down to a height of 7 centimeters? Okay, so if your height is 7 centimeters, okay, that means we're looking for t. So h of t is equal to 7. H of t is equal to negative 2t plus 12. So that means that 7 is equal to negative 2t plus 12. And then we just solve for t. So I'm going to move that 12 over. Okay, so 7 minus 12 is minus 5. And then I still have negative 2t on this side. And then when I solve for t, so negative 5 divided by negative 2 is 2.5. And of course that's in hours. And then the last one, suggest an appropriate domain and range. Okay, well my domain is going to go from 0 to 6. 0 to 6 hours. Okay, so domain t is such that, and then you remember you put t in the middle, 0, 6, okay, greater than, less than, greater than, less than. T is an element of the real numbers. Okay. Then my range, h of t is such that, okay, so then same thing, 0 to 12. And h of t is still an element of the reals. There, done. So in this question, we used everything that we've learned so far about functions. So function notation, graphing, x and y intercepts, domain and range, and then just that logical component where we're actually thinking, okay, what does this question mean? Or what does the data mean in the context of the question? Okay, so you've got time to work on that. Have a lovely time. Help each other out.